Who is on the embed cloud? Who are you building that on top of? Is it Azure? Is it AWS? Who's your partner on the cloud service?
So we have not publicly announced that. I will say that we're firm believers in the cloud, so we use the cloud. We're not establishing our own data centers or anything like that. I can't say that, who it is, but I will tell you that our expectation is, in our roadmap, we will be doing a lot of private cloud type deployments, meaning it will probably run on just about any cloud. So if somebody would prefer, for example, embed cloud to be deployed on, if they've chosen Amazon or IBM or whatever, there's nothing keeping us from doing that. But right now, we use a major global provider today, pretty well known. And but the other component here is embed cloud itself also has the ability to kind of deeply integrate with any cloud. There isn't anything keeping it from connecting to pretty much any cloud on the planet.
Okay, thanks.
Hi, Jim Harrison. About embed, there's no ABED, right? So embed is for M cores only. What do people do with A's?
Yeah, so great question. The embed cloud announcement also includes some other capabilities. When we start talking with some of the OEMs about helping them with their IoT solutions, they have sometimes very heterogeneous kind of deployments, different processors, different operating systems, but they want to be able to manage them all from one place. And so we've created something we call Embed Cloud Client, which is really a software module that you can use to essentially drop into a different OS, and could be on a Cortex-A based device, could be on some other architecture. We don't really care. These are important, when we talk about an OEM deploying, maybe he's got routers or gateway devices which are a different architecture, maybe running Linux. We do have a module that can drop into there and integrate and provide some level of management as well as the other devices within the IoT deployment.
And that's available now?
That is available now.
Back there, then you can. Yeah. All right, cool.
My name is Deepak Puri. I write for Network World. My question is, given the recent spate of attacks from IoT devices being used for DDoS attacks, how is ARM, two related questions. One is, the devices which are already out there, which might be vulnerable, what is ARM suggesting to its OEMs that they should do about it from those devices being used, from being compromised and being used for attacks? That's question one. Question two is, now that there's this high level of anxiety that these devices could be misused, what is ARM suggesting to its OEMs on, best practices going forward?
So, Nandan, you want to take the first one there?
But no, I'll start. The devices that are out there, there's a real limit to what we can do about that, and most of those attacks are based around unpatched root passwords, admin, and from a technology point of view, there's nothing to be done. That is a user side problem. I guess going forward, what we see is that provisioning part about when you first bring up a device and how you provision that device, create it with unique IDs and unique passwords when it first comes online, so it's never there with admin blank as the root password.
Yeah, I think if you look at the overall, that's the whole basis of trust zone when you do it. You need to set it up for secure boot first before you let the open part of the operating system use it. So that's, I think, becoming obvious that we need to do a better job of doing that. The technology, we believe, at least the first generation, is there. In the microcontroller world, people are using proprietary security standards as well. Now it's a question of when you're implementing it, it's a hardware-software problem that needs to be resolved, right? So most of the techniques that will make it more secure out there, now it's a question of executing on them. What the next generation does with us, and that's why we talked about the IoT platform going forward, is that the entire system and the key software stacks tested together will help establish that base faster, because otherwise you do need a lot of security history to do it right.
Can I build on that for just a moment?
Yeah, okay, thank you.
Yeah, so I think there's little that can be done about baby monitors everywhere with admin, combinations. These things will hopefully eventually be taken out of service. However, we're firm believers that security really needs to be designed in from the start. It's not an afterthought, you can't bolt it on afterwards. And so that's why we've really developed the Embed IoT platform with Embed OS with really the security in mind from the start, and having its ability to kind of integrate deeply into the ARM Cortex-M architecture, and setting up secure communications, as Mike was saying, during the bootstrap process, establishing security and control, and ability to restore order and be able to do firmware updates. Just a lot of these devices, you can't do that either, right? Big problem. So the Embed IoT platform is intended to kind of solve that and to really help between really the hardware all the way, for the software running on the device, all the way to the cloud, having end-to-end security, the chip-to-cloud security, and eventually making that kind of a table stakes. I think IoT just can't take off unless that's solved. You're just going to run into these problems all the time.
Yeah. Everyone's had a go at it, but the other thing I wanted to say is sort of if you think about ARM's DNA, it's about finding the right line between standardization and innovation. We've got to have standardization so there's an ecosystem that coalesces. We've got to let our partners do innovation, and there are some fundamental things that have to be built in a consistent way. And I think you see with the announcement today, what we're trying to do is saying, here are some things that need to be pulled together in this particular way. And you'll see us over time doing more around platform specifications, really trying to help partners build platforms in a consistent way.
So we have Tim first, then we'll grab you first.
All right. Interesting numbers concerning the number of devices out there this morning. A trillion is a big number. I only really care about the data center, so all that stuff pushes back into the data center. I didn't see any projections for what this does for serving back in the data center, and then what your piece of that's going to be.
Fergie, you want to take that one?
Well, no, I was just going to say I'd done a kind of off the top of my head calculation, which I don't think is right, but it was like kind of, you got to start thinking maybe it's one IoT device, maybe 10,000 to a server.
Okay.
And just in my head, I kind of did 10,000 devices, and then if you say maybe all the servers in the world are going to take 20% of the energy supply, you end up kind of going, then each server has to run about 15 watts, which is doable. It's an order of magnitude better than where we are today, but if you say that was 1 trillion in 2023, I think it was. So is there a good business to be had in servers? Yes, I think there is. What's the ratio of IoT device server? I don't know, is it 1 to 10,000? Is it 1 to 100,000? Who knows, but it's plausible. But yeah, it will drive traffic, and as you see, it'll drive not only the data rates, but the number of servers. But it seems to kind of scale.
Excellent.
That's it.
Thank you.
Okay, adding a software as a service business to kind of your licensing business, I'm wondering what parts of your sales organization, your customer kind of relations organization, how does that change going to this new type of business?
Do you want to say that?
I can tell you how things are today. So the IoT business unit, in terms of selling software as a service, selling Embed Cloud, we do have a dedicated sales team and a support team, which is essentially a SaaS savvy, SaaS savvy kind of sales team with a lot of technical support there. IoT is still reasonably in the early days, and so there's a lot of companies that need a little extra hand-holding, I think, in terms of deployment and getting the technology up and running. It kind of varies all over the map. So structurally, that's a dedicated team that's actually reporting to the IoT business unit. A little more detailed than maybe you want. Going forward, as that business grows, I think it's still, in terms of how we structure things on the commercial side, I think it's, we have something that works today, and we'll be looking at it depending on the scale that's needed.
Yeah, I mean, the sales skills are slightly different, but then that's true in our base business in licensing the CPUs, licensing some of the software components. What we do with physical IP is actually quite different customers than what we do with the RTL. I think the bit that's very common between them is we understand well what it takes to build a partnership and an ecosystem of competing players and bringing them together, and that's true whether it's all clustered around a SaaS service or whether it's around a CPU architecture. So there's still an awful lot of overlap in the way ARM goes about its business, even if the sales level skill set is slightly different. There's also a support side that's slightly different. We have to run 24/7 in a different way to what we have with our current back-end services. So yeah, it is taking us to new places.
Nandan, a couple of questions on M33. Can it be thought of as M4 plus TrustZone plus V8M? So from an architecture viewpoint.
So firstly, I think if you look at the basis of M4 that started on the M3, which was nearly 12 years ago, so we did, for the M33, look at redoing it from scratch with all the things we've learned. So it is much more efficient design than the M3 or the M4 for that matter. From an architectural perspective, there is ARMv8M adds more than just TrustZone. So that's something that we need to take into account, and those things come in how it actually operates with exclusives around multiple microcontrollers on the same die, which is going to happen, and often you will see the M33 and M23 working together or with others. So how do you make that more efficient? That's all built into the M33. The other area that we focused on is to make it that much more configurable because it represents such a diverse market. So it does have more compute capability in terms of floating point and DSP over and above what the M4 had. So you look at all these things together, it's easy to say it's M4 plus XX, but it is its own new product, more efficient, more capable.
And can you talk about the differences between TrustZone on M-class processors and A-class?
Sure. So from a TrustZone perspective, the A-class, obviously, those types of devices run larger operating systems, have a much larger or less constrained, shall we say, larger memory, so on and so forth. And the goal of those is not to have immediate real-time response, right? And they have enough megahertz to make up for some of those response times. So the way TrustZone was set up was to have a software secure monitor that helped separate the non-secure side from the secure side. Now the concept of the secure and non-secure continues, but being a microcontroller and needing much more guaranteed response times, you can't rely on a secure, even a hypervisor type approach. So these are much more instruction-based, where you have transitions from the secure to non-secure. If you get access, be sub 5 cycles. In fact, it's in the order of 1 or 2 cycles. So it really retains all the benefits of a microcontroller that the Cortex-M had, plus it retains the benefits of not needing that extra software cycle, because these are very memory resource-centric or constrained operations.